Slope is a very important thing when it comes to linear functions and functions in general, and we spend a lot of time talking about slope whenever when we're dealing with graphing. So slope is a way of defining how steep a line is. So some lines, if you think about it, some lines are going to be more steep than others. If you were to place a ball on that line, sometimes the ball would roll faster, would pick up speed faster than others. And so we also call it the rate of change between x and y. And so we have formulas basically to represent it. So if you're given 2 points, x1, y1, and x2, y2, which we see a similar notation crop up in math, like when we deal with circles or distance formula or things like that. The slope is given by m equals, in words, it's the rise over the run. It's how much do I rise between the 2 points over how much I run between the 2 points. The other way of saying that is that it's the change in y over the change in x. So that's this part of the formula. So all of these things are equivalent. These are different ways of thinking of it that all mean the same thing. We can say the change in y over the change in x in a mathematical way by saying it's delta y over delta x. This triangle is the Greek letter delta, and it means change. So change in y over change in x. Or if you just want a formula to plug into, that means you take the second y value minus the first y value over the second x value minus the first x value. So, depending on what kind of information they give us, that's going to be how we approach finding the slope. For example, on part A, they've given us a line. It looks to me like this is a good point, 0, 1. And I need another point now like this one. And you always, or it's most helpful to look for points that actually cross, like for sure cross at a grid line. Okay, so some of these may have been close to crossing through a grid line, but just weren't quite close enough. If we're given a graph, we can actually count starting from either point and say how much am I rising, how much am I running. And so from here, I would rise 1, 2, because keep in mind what the scale on this is. So 1, 2, 3. I'm actually falling 3 from the first point to the second point. So that is a rise of -3. Okay, anytime that you rise down, you're actually going the negative direction. So now I run, and when I run, since I'm running to the right, that's a positive value. I run, that's 1, that's 2, so that's +2. So our slope is -3/2. Now we could have gone about that a slightly different way. We could have counted from this point that we went up 3, and then we would have ran a -2, and that still ends up giving us -3/2. Okay, so you just have to pay attention to, am I rising a positive or negative direction, and am I running a positive or negative direction? Now, here we have some horizontal and vertical lines, so we have to think about what the slope would be. And for a horizontal line, if you think about it, your slope, you don't really have any slope, right? There's no slope to this because it's just flat. It's a straight line. And so for our horizontal line here, our slope is actually 0, okay, because our line is not going up or down at all. To contrast that, our vertical line is only going up and down. It has no run whatsoever. Okay, so actually you can think about it like this. We are rising any number we want. Like you could say, oh, between 2 points I'm rising 5, but I'm not running at all. Well, a 0 on the bottom means that this number is undefined. And so that is the slope of any vertical line is undefined. any horizontal line will have a slope of 0. And so we could have done the same thing where we're saying we're rising 0, but we could run 4, for instance. Well, that gives us 0 for our slope. Now we want to look at some situations where they gave us some points. And so remember that labeling this as x1, y1, x2, y2, and then we just plug into the formula. So I would have 1 minus 3 over negative 2 minus 8. We do the top, 1 minus 3 is negative 2. The bottom, negative 2 minus 8 is negative 10. I simplify that. Negatives, a negative on top and a negative on bottom, those cancel each other out. And then 2 over 10 can be simplified to 1 over 5 because we can divide the top and the bottom by 2. Same thing on D, x1, y1, x2, y2. So I have negative 6 minus 2 over 3 minus 3. On top, this is negative 8. On bottom, 3 minus 3 is 0. You cannot divide by 0, just like before. So that means that this is an undefined number. So it's an undefined slope. And one way, if you have issues remembering that that's what happens, that you can't divide by 0, is if you plug into your calculator negative 8 divided by 0, it should give you some kind of an error. And it probably, the error actually says something about you can't divide by 0. So that's a way to remember when you get that error, then your slope is undefined. So E we have negative 2 minus negative 2. So those minuses next to each other actually make a positive. And then 4 minus 0. So change here, or whatever you do to remember that. Those are two negatives, so they make a positive. That gives us 0 on top and 4 on bottom. 0 divided by 4 is 0. So our slope for E is 0. And this last one here is actually the easiest, as long as you remember what slope-intercept form means. This is y equals mx plus b. And remember, does m or b tell us the slope? Well, m tells us the slope, which means the slope of this line is 3.